Hello Collins Cobras, this is Mrs. Hernandez from LC62 and today I'll be hosting your video over writing equations from tables. Tables show the relationship between independent and dependent variables. You can use a table to write an equation that shows the relationship between the variables. So as a review, we're going to use this situation to decide which is our independent variable and which is our dependent variable. Katie eats 2 more cookies than her friend Jamie. In this situation, to me, it's easier to identify the dependent variable first. And the number of cookies that Katie eats depends on how many cookies Jamie eats. So our dependent variable is going to be Katie's cookies, because it depends on the number of cookies Jamie eats. And then that makes our independent variable the number of cookies Jamie eats. And our independent variable is represented by x always, and our dependent variable is always represented by y. Okay, so to write an equation from a table, the first thing you're going to do is find the relationship between x and y. And remember that relationship can be multiplicative or additive. So to use this table as an example, we want to ask ourselves, well, what can we multiply by 1 to get 3, and what can we add to 1 to get 3? And then after we've decided what the relationship is between 1 and 3, we have to make sure it's the same pattern for all of the values of x and y. So to start with, we could multiply 1 times 3 to get 3. And then 2 times 3 would have to be 4, which is not true. So this is not a multiplicative relationship. It has to be additive. So what can we add to 1 to get 3? And that's going to be adding 2. And does that relationship work for our other values? 2 plus 2 is 4, 3 plus 2 is 5. So how do you get from 1 to 3? 2 to 4, and 3 to 5. And was the pattern the same for all? Yes. So since we could answer yes to this question, that tells us that we can write an equation based on this relationship from this table. And our relationships, our equations for 2 variable relationships always start with y equals. And then what was the change that happened to x? So it's always y equals and then the change that happens to x, and in this case it was x plus 2. So whatever the x value was, plus 2 gives us our value for y. Okay, we can also write equations from graphs. There's only one extra step when we have to do that. The extra step is going to be to take the graph and make a table with the ordered pairs from the graph. And then to take that table to determine the rule, which is a synonym for the equation. Okay, in this table here, it looks like some of the numbers got skewed. So on the y-axis, this should be 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay, so when x is 2, y is 4. When x is 4, y is 8. And when x is 6, y is 12. So we want to ask ourselves, what is the relationship between 2 and 4? That's where we want to start. There are two options. It could be 2 times 2 or 2 plus 2. So 2 times 2 is 4, and 2 plus 2 is 4. So then if it was adding 2, 4 plus 2 should be 8, which it's not. So it cannot be an additive relationship. We can also tell it's not an additive relationship because the graph passes through the origin. So only multiplicative relationships pass through the origin. So it has to be multiplication. 2 times 2 is 4, 4 times 2 is 8, 6 times 2 is 12. It works for all of the values in our table. So times 2, times 2, and times 2. Again, the equation is always going to begin with y equals, and then what change was made to x? It was 2 times x to get our value for y. Okay, let's do a few more examples. So here we've got a table that represents rental bike cost. And we're going to start by looking for the relationship between 2 and 13. We know it could be multiplicative or it could be additive. If it was going to be additive, it would be what can we add to 2 to get 13? So it would be plus 11. And then if it was going to be multiplicative, what can we multiply by 2 to get 13? And if you don't always know that, here's a tip. You can always work backwards. So to go from here to here, we would want to multiply. To go from x to y, we would want to multiply. If we're trying to find out what we're multiplying by, we can always go backwards. And when we go backwards, we use the inverse operation. So 13 divided by 2, which is 6.5. So it should be times 6.5 if it's multiplicative, because 2 times 6.5 is 13. So let's check for an additive relationship with the rest of the values in our x column. So 3 plus 11 should be 1950, which it's not. So this is not an additive relationship. It is multiplicative. So it's going to be 2 times 6.5 is 13, 3 times 6.5 is 1950, and 4 times 6.5 is $26. So our equation is y equals, it always starts with y equals, and the change that happens to x is multiplied by 6.5, so 6.5x. Okay, let's move over here to this table that represents John's age. So starting with the first two values that we have in our table, so 5 and 11, it could be a relationship of plus 6, or it could be a relationship of times 2.2. And the way that I found that was I did 11 divided by 5 and I got 2.2. So 5 times 2.2 is 11. So let's finish checking for an additive relationship. 7 plus 6 should be 13. 9 plus 6 should be 15. So it is an additive relationship. So y equals x plus 6. Okay, and then let's take a look at this example here. So this time we're going to look at this first value for x and y and look at the relationship. I can tell that my value for x is greater than my value for y, so there's a decrease here. and 12 minus 5 is 7. 10 minus 5 is 5, and 8 minus 5 is 3. So our equation is going to be y equals x minus 5. And you might be thinking, well, the only relationships we can have are additive or multiplicative. And x minus 5 is actually an additive relationship because it could also be written as y equals x plus negative 5. These two equations are equivalent. You'll most frequently see it written in this way, but it's still an additive relationship even when it's written in this form. All right, and our last example is going to have us use a graph to make a table and then write the equation from there. So when x is 2, y is right here in between 4 and 6, which is 5. So when x is 2, y is 5. When x is 6, y is here in between 8 and 10, which is 9. So when x is 6, y is 9. When x is 10, y is 13. And when x is 14, y is 17. So I'm going to start here with my first value for x and y, and the two possible relationships would be 2 times 2.5. 2 times 2.5 is 5, or 2 plus 3 is 5. So if this was to be a multiplicative relationship, then 2 times 2.5 is 5. 6 times 2.5 should be 9, and that is not true. So it's not a multiplicative relationship. So it should be additive. So 2 plus 3 is 5, 6 plus 3 is 9, 10 plus 3 is 13, 14 plus 3 is 17. So the same rule works for all of the values in our table. So we've found our relationship, and we're going to write that in the form of an equation, y equals, and then the change that's happening to our x values is we're adding 3. So y equals x plus 3. I hope you have a fantastic rest of your day. Don't forget to do the practice page following this video.